For Module 7, please make sure that you have your formulas for the arithmetic sequence as well as the geometric sequences. That includes finding the nth term as well as the sum. For arithmetic sequences, there's only one formula to find the sum, and geometric has two depending on if it's infinite or finite. Um, so we're going to look at the first example and we're going to find the next term as well as write an expression for the nth term. So if I look, just to find the next term, I don't actually even need a formula. I can just kind of follow the pattern. So to get from 1 to 3, you could either add 2 or you could multiply 3. How do I know which one it is? Well, I should be able to do the same thing to get from the second term to the third term. So in this case, it would be adding 2. So for each term, I'm going to add 2 to get from one term to the next. So the next term after 7 would be 9. Just keep adding 2. Now, because I'm adding 2, this tells me that this is an arithmetic sequence because I'm adding and subtracting the same value to get from one term to the next. So to find the nth term, I'm going to use the formula to find the nth term of an arithmetic sequence. There is more than one. I like this one, which is dn plus c. So the difference we already have. The common difference is 2. N represents the term I'm looking for. So since I'm not actually looking for any specific term now, I'm going to leave it in terms of n, but this would be handy to use if you're looking for, let's say, the 100th term and you don't want to just keep adding 2 again and again and again. For C, C is the first term minus the difference. So if I look at this sequence, the first term is 1 minus the difference, which is 2. C would equal -1. So replacing c with -1, because I'm not going to put plus -1, just -1, I have my nth expression. So for the next one, I'm going to go from 1 to the next, one term to the next. So notice in this case, how do I get from 2 to 5? Well, I could add 3, but I can't actually do that for the next one. I can't multiply anything. So in this case, I'm going to use this trick of writing n above each one of the numbers. So n equals to 1, meaning the first term is 2. N equals to 2, second term is 5. N equals to 3, third term is 10. N equals to 4, the fourth term is 17. How do I go from one number to the next? Well, I'm going to look at the relationship between n and the actual term. So how do I get from 1 to 2? And that should be the same method I get from 2 to 5. So let's see, I could times 2, but I can't times 2 here and get 5. So I can't times 2 to 3 and get 10. Now keep in mind, there's only so many things I can do. I can't multiply the same thing. I can't divide, that would make it smaller. I can't subtract. Adding doesn't work. What's left over? Exponents. So I'm going to see what I can do here. 2 to the second power would give me 4. 4 plus 1 is 5. 3 to the second power would give me 9. 9 plus 1 is 10. 4 to the second power is 16. 16 plus 1 is 17. So here, I would take the n, which is the number of the term, and square it and add 1. Are they all going to be like this? No, but I wanted to show you something different as well. So this would be my nth term. So don't rely so much on the formulas at all times. Sometimes you can kind of just use this method as well. Now, since I am looking for the next term, but I couldn't find the pattern here, I'm actually going to use the formula for the next one. So this is 1, 2, 3, 4. I'm now looking for the fifth term. So I'm going to replace the n with 5, and I will get the fifth term equals 5 squared plus 1, which is 26. And then here, I am looking for the sum of the numbers from 1 to 30 given a consecutive sequence of numbers. So that means 1, 2, 3, 4, all the way to 30. So because if I were to have a sequence of numbers from 1 to 30, notice that there's a common difference of 1. So I add 1 to get from one number to the next, making this an arithmetic sequence. Again, there's only one sum formula for an arithmetic sequence, and it would be n over 2 times a sub 1 plus a sub n. N represents the total number of terms. Well, if I'm going from 1 to 30, there's 30 terms. So I'm replacing all the n's with 30. A represents the number at that term. So a sub 1 means the first term. What's the number there? That's 1. Plus a sub n. Well, we've already established n is 30. So a sub 30 means the 30th term. That would be 30. So using your PEMDAS, make sure you solve for the parentheses first, then multiply, and you can put the whole thing over 2. And you should get a total of 465. I hope this helps, guys.